What makes a gas pump stop with that sudden click? It is not a timer, and the pump does near the tip of the nozzle, and you will find a tiny sensing hole. While fuel flows, a venturi inside the handle creates suction and pulls air through that hole. As long as air can enter, the trigger stays latched. But when rising fuel covers the hole, the airflow stops. The pressure changes, a diaphragm moves, and the spring-loaded valve snaps shut. That click is a completely mechanical liquid detector. And the next tiny hole has a much more personal job. Why is there a hole in the cap of a ballpoint pen? On vented caps, it is a safety feature. A small cap can be inhaled accidentally, especially by a child. The opening gives air a path around the obstruction and helps reduce that risk. BIC says its vented caps comply with ISO 11540, a safety standard intended to minimize the danger from inhaled pen caps. The cap still protects the pen point, but the hole turns an ordinary piece of plastic into a tiny breathing passage. Now look at a detail that can save you from parking on the wrong side of a gas pump. Beside the fuel pump icon on many dashboards is a small arrow. It is not showing the direction of fuel flow. It points toward the side of the vehicle where the filler door is located. Left arrow, left side door. Right arrow, right side door. Ford and Mazda describe exactly that function in their owner manuals. Once you notice it, you stop leaning out of the window and guessing. The next mark is harder to see and much more important. Run a finger through the main grooves of a car tire. Those small raised bars are tread wear indicators. They are molded into the tire at a specific height. As the rubber wears down, the tread eventually becomes level with the bars. In the United States, passenger car indicators correspond to 2/32 of an inch of remaining tread. NHTSA says tires at that level should be replaced because their traction has become unsafe. The tire does not need a sensor or an app. It reveals its own wear by changing shape. Halfway through, here is the rule: if a detail looks unnecessary, it is probably solving a problem you cannot see yet. Take the tiny opening or drainage channel at the bottom of an outdoor padlock. Water can enter around the shackle, carrying dust and grit with it. If that moisture stays trapped, internal parts can corrode or freeze. Drainage paths give water and debris a way out. Some lock designs even use the shackle's movement like a small piston to help push contamination through the drain. The hole is not damage. It is an escape route for everything the lock needs to survive. But one door is covered with holes and still blocks something far more energetic. The dark grid on a microwave window is a metal screen. You can see the food because visible light has a tiny wavelength and passes through the openings. Microwaves have a much longer wavelength. The holes are far too small for that energy to pass through efficiently, while the conducting metal reflects it back into the oven. That is why you can watch the food spin without standing in an open microwave cavity. The glass lets you look in. The mesh helps keep the microwave energy in. Now grab a drink and look at the tab before you open it. The tab is a compact lever built around a rivet. When you lift the wide end, the rivet acts as the pivot and the short nose pushes down on a scored section of the lid. Concentrating the force near that score starts the tear with much less effort than punching through the aluminum directly. Modern stay-on tabs also keep the open panel attached to the can instead of leaving a sharp loose piece. One stamped part gives your finger leverage, breaks a controlled weak line, and stays connected after the job is done. The final hole works at cruising altitude. An airplane passenger window is not one sheet. It is a layered assembly with a small cavity between structural panes. During climb and descent, cabin pressure changes. The tiny breather hole allows slow airflow so pressure in that cavity can equalize with the cabin. Boeing describes it as a way for the window assembly to breathe with pressurization changes. The outer pane normally carries the pressure load, while another structural pane remains available as backup. The same airflow also helps manage moisture between the layers. So that pin-sized opening is not a leak to the sky. It is part of the pressure system. A click, an arrow, a raised bar, a mesh, and a few tiny holes. The smallest details are often doing the most serious engineering. Subscribe to MECHANOFACT and keep looking closer.